Hey, grade 8s from St. Mary. It's Mr. McHenry here. And just want to say hi to everybody and hope everybody's doing well, staying safe. We're back in our math class and using the whiteboards. And today we're going to do a little bit of review on the surface area of a cylinder. And just to start, we want to confirm what surface area is, and that is the total area of the surface of an object. So, if you remember our rectangular prism, the Cheerios box, is that if we wanted to calculate the surface area of this box, we would need to find the surface area of each of its sides. So for example, for the front here, we would find the length times the height, and so on for the top and the bottom being the same, front and back, and left side and right side. So finding the surface area of each of its sides, adding it together to find the total surface area. So using that background knowledge, we want to look to find the surface area of a cylinder. And what do we notice about a cylinder? Well, a cylinder has 3 sides. So the surface area of a cylinder, we have 3 sides. We have a top, we have a bottom, and we have this curved side right here. And what do we know about those curved sides? What do we know about all those sides? Well, we know that the top is a circle, and the bottom is a circle, and this curved side we're going to get to in a second. So we're just going to leave that for a second here, and we're just going to focus on the 2 circles. So we have 2 circles here, and they're actually identical circles or congruent circles. And we know from our background knowledge that to find the area of a circle, well, that is pi times r squared. And obviously, being congruent circles or identical circles, that is for the bottom circle, it's also going to be pi times r squared. And we know that because this is repeated addition, that then we have 2 of them, that we can say it is equal to 2 times pi times r squared. So we've covered the surface area of the top and the bottom, but now we gotta figure out this curved surface area. And if you remember in class, what we did is we had to do a little bit of cutting with this. And what we did is we cut the cylinder and when we unraveled it, what we found out is that this curved side actually turns into a rectangle. So now we have this rectangle. This curved side is actually a rectangle. And we know a little bit about that rectangle, and it has a height, h, and it also has a length or a base. We'll call that b. Okay, and we know from our background knowledge to find the area of a rectangle is equal to base times height. But we also know something about this base right here. Because when we take it away and we put it back together, it forms a circle. And the outside of a circle, if you remember, is called the circumference of a circle. So we know that this area here, the base, when we unravel it, is actually the circumference of a circle. So we can change that base, that b, into 2 times pi times r, and then we can bring down that h times h. So to calculate the area of this curved surface, which turns into a rectangle, is 2 times pi times r times h. And now we have all three surfaces, and we can bring it together. So we have the formula for the surface area of a cylinder is the area of two congruent circles plus the area of the rectangle. And the area of the two congruent circles is 2 times pi times r squared. And then we add the area of the rectangle, which is 2 times pi times r times h. And that is the formula for the surface area of a cylinder. Now, let's put this into practice. So we have an example here, and the example is a question that reads, a manufacturer produces a cylindrical can with height 7 centimeters and diameter 5 centimeters. What is the surface area of the can to the nearest centimeter? So we want to remember our thinking and communication chart, and we want to say, what do I know? Well, one thing that I might want to do is I might want to draw a picture of this cylindrical can. So I've got my picture, and the second thing that I might want to do is I might want to label that picture now from the information. So I know that there is a height of 7 centimeters. And the height or the length of a cylinder is always on the curved side. So when you get questions that say height or the length of the cylinder, that always goes on the curved side. It also says that I have a diameter of 5 centimeters. So I've labeled those things on there. And what do I want to find out? Well, I want to find the surface area of the can. Well, what is a can? The can is a cylinder. And I have a nice formula that I can use. So surface area of a cylinder is equal to 2 times pi times r squared plus 2 times pi times r times h. And now what do I want to do? I want to, remember, math referee always does some substitutions or replacing here. So I look at my formula and, oh, I got an r here and an r here. I don't have an r in my diagram, so I got to figure out the radius. So how do I do that? Well, I can use my diameter. So radius is equal to diameter divided by 2, which is 5 centimeters divided by 2, which is r is equal to 2.5 centimeters. So now I can go in and I can replace or substitute in So I keep 2 times pi. I'm going to leave pi as the symbol. Remember, it's 3.14 or about 3.14 times 2.5 squared plus 2 times pi times radius, which is 2.5, times height, which is 7. And I'm going to go ahead and solve here. Now we have to be careful because we have to know that this is 2.5 squared, not 2.5 times 2, but 2.5 squared, which is, if you need to write it out please, 2.5 times 2.5. All right, and I do a calculation here, and I know that this is 2, and sometimes it's easier to do it a little bit longer. I'm going to put in 3.14 here for pi. 3.14, 2.5 squared, or 2.5 times 2.5 is 6.25 plus, and I'm just going to keep this as is, okay, for now. So I've got everything substituted. I've got using my BEDMAS rules, and I go ahead and solve. So this first part here goes to 39.25 plus the second part here multiplies to 109.9. I add those two together and I have 149.15, and remember it's area, so it's centimeters squared. Now the question asks to the nearest centimeter, so we got to use our rounding skills again. All right, we were working on these to make sure everybody's got good rounding skills. So what am I rounding to the nearest centimeter, which is in the ones column right here? So where do I need to look? I need to look into the next column over to the right, which is the tenths column. We use our rounding rules, which is 5 and up. We round up. Less than 5, it stays the same. So 1 is less than 5. So this rounds to approximately, that little decimal or that little dot on top means approximately 149 centimeters squared. So that's our lesson on the surface area of a cylinder, and you can look for additional pages in the D2L site for questions that you can be working on.